Yep, the stream, yep, stream should be good.
All right, great. So thanks for joining us, everybody, today. Tonight we have Nathen Harvey, who's a developer advocate for Google, who's going to be talking to us about site reliability engineering. He has been working to help communities understand DevOps and site reliability engineering practices in the cloud. And he's part of the DevOpsDays conference's global organizing committee and a technical reviewer for the Accelerate State of DevOps report. So super excited to have Nathen with us. As many of you know, like our theme around the Dev Alliance this year has been DevOps. So not only is it super cool to have a talk on site reliability engineering, but also this is our first talk from any of the big FANGs. And so tonight, super excited to have our first Googler with us. So Nathen, thanks for taking the time, and I'll let you take it away from there.
All right, awesome. Thank you so much. I'm really excited to be here. Thank you all for having me. And yeah, let's just jump right in. So let me share my screen, make sure that you can see that. Okay, so can you see my slide and nothing but the slide? Can't read my email right now or see all my password safe open. All right,
looks good to me.
Good.
I can feel the private keys to Google, but other than that, yeah, you're fine.
Yeah. I'm sure I've got a password or three in somewhere that you can find. Right. So this, I'm really excited to be here, and it's interesting to hear, and maybe we'll have a chance to discuss like the theme that you have is DevOps. One of the questions I always have when people say like, "Hey, I'm really interested in DevOps," or "We're doing DevOps," or "Our theme is DevOps," is just what does that mean? When you say DevOps, what does that mean? And I think, there are at least a dozen of us here. I think if we paused right now, we could come up with 13 different definitions out of the 12 of us easily. So maybe we'll have time for that towards the end. But tonight, this evening, I want to talk about SRE, or Site Reliability Engineering. So let's see, make sure I'm good to go. There we go. So this is me. My name is Nathen Harvey. You can follow me on Twitter if you like. Just one word of warning. My father thought it would be awesome if he misspelled all of his children's names because, frankly, he was a visionary. In the early 70s, he thought one day my children are going to need a way to globally, uniquely identify themselves. So if I fuck up the spelling of their name, they'll thank me forever. And I'm not sure he was right, but I do remember. And unfortunately, there's it's not unfortunate. But there's a guy who's in tech. His name is Nathen Harvey, and it's spelled properly. Globally, uniquely identify themselves. The funny thing is, I think he recently forwarded me something from my insurance company. To need a way to so globally, it's like we're good friends. I don't think we've ever met, but one day I'll be able to travel again, and we will. Anyhow, enough about my name. You didn't come here to learn about that. We're here to talk about site reliability engineering, or SRE. So SRE it's a set of principles and practices that have been developed over, past decade or more within Google. Google finds that it works pretty well. It certainly works well for us. And there are lots of other companies that have adopted it, have adapted it, have thought about these principles and practices, made them work with what they're trying to accomplish. So when we think about Google, the way that we describe it is we believe that it is what you get when you treat operations as a software problem. The mission of SREs at Google is to protect, provide for, and progress software and systems with an ever watchful eye on their availability, latency, performance, and capacity. So SRE itself is really founded on three principles. The first principle is that the most important feature of any system is its reliability. Now, sometimes when we say this, I think it can land as controversial. Sometimes, people ask, well, is reliability really a feature? And oftentimes what I hear is people say, yeah, of course, reliability is a feature. It's one of those non-functional requirements that we have. Well, I tell you what, I hate that word, non-functional requirements, right? Most people, when they describe non-functional requirements, they think of them as features that the user doesn't ask for. Things like scalability, security, reliability. These are all non-functional requirements. But guess what? If your system doesn't meet those non-functional requirements, it's probably not functional. Like, who would want to use that system? So anytime you or your colleagues are tempted to or come across the words non-functional requirements, please, my one request tonight is please just stop calling them that and call them operational requirements. Building software is important. Building software that is reliable, that is operable, is where we get real value. So reliability is definitely a feature. It is one of those operational requirements. And it's really, really fundamental to the practice and the approach and the principles of SRE. Our second principle is that our monitoring doesn't decide our reliability. Our users do. It is very easy to get signals out of your systems. You probably right now, for any system that you're running or that you're associated with or your coworkers are working on, there's probably a graph somewhere on a machine, on a monitor, on a wall that shows you what is your CPU utilization. How much free memory do you have available? Your users don't care about that. All your users know is that the site is broken. And sometimes your monitoring doesn't show you that. I can tell you, I've spent, I am a developer advocate right now, as Jeff mentioned, but I've spent many years building, running, operating software. And there was one company I was working at where I got a call from my boss. It was a Saturday afternoon. Boss said, Nathan, something's definitely wrong with this site. You got to fix it. So I said, all right, hang on, boss. Let me log on. Logged in, pulled up my dashboards, said, nope, everything's green. We're good to go. I was wrong. He was right. But how many times has this happened to you where you looked at all of your monitors, everything looks good, but Twitter told you that your application wasn't working the way that you expected it to? The reverse is also true, though. Raise your hand if you've ever been woken up in the middle of the night about something that didn't matter. I certainly have, as being on call. So this is our second principle. Our monitoring doesn't decide our reliability, our users do. And the third principle that we talk about within SRE is that meeting our reliability goals requires well-engineered software. We have to start with good software. But that's all we're doing with it. We're starting there. We've learned that great software isn't enough. To meet our goals and our promises, we need operations that are aligned around meeting those goals as well. And we need business practices that empower both of those teams or everyone along that chain. Perhaps most importantly, we need all of these people to share a mission. And for that, we need a shared language. And the shared language is so important because it's human nature to focus in on the thing that matters most to you. We are going to argue with one another, but we need to argue effectively. And to argue effectively, we need to have a shared language. So SRE helps us move away from making decisions by shouting louder than everyone else, or by waiting for that person who you disagree with to leave the company or to leave your team. In other words, make decisions by attrition, or people just giving up on their ideas. SRE gives us a language, the language that we need to work together, and a principled way to argue about the desired reliability of a service. So we can ask questions like, what are we going to promise? And to whom are we going to make those promises? How do we define what good means in the context of a service? And how much good do we need? And probably more importantly, how much good do our customers need? So let's dive right into the language of SRE. And SRE is founded on S's. There are 3 S's that I'll cover with you right now. I guess it's 4 since we already talked about SRE. That happens to be an S, right? So let's start with an SLI, a service level indicator. A service level indicator is a metric, but it's a metric that tells you or indicates the level of service you're providing. Here's the thing about SLIs. An SLI is always from a user's perspective. So how does a user experience your service? How does a user know if your service is working? How does a user know if that service is broken? So let's say maybe you're an insurance provider, and one of the things that your users use this application for is to request a modification on their policy. Was that request successful? That is something that a user cares about. Or let's say you're interested in purchasing a home. If you see a listing that is interesting to you and you click on that listing for more details, do you get those details? How fast do those details come back? These are indicators for you on whether or not that service is working. So that is an SLI, a service level indicator. It's a customer-centric or user of your service. How do they know? What signals do they have to know if your system is working or not? And of course, they won't necessarily use the same language like availability and latency, right? Depending on who your customers are. But they do know that and they do experience it. So our next S is a service level objective. So this is a target for the overall health of your service. So let's go back to that insurance provider. You requested a modification to your policy. Well, we need to look at all of those policy modifications. How many of those do we typically receive? How many of those do we need to ensure are successful? Is half of them being successful sufficient? Maybe there's two paths for processing or processing those modifications. Maybe a user can do it self-service on the web, but maybe if it's a complex modification, we might capture that and then hand it off to another system. How many of those do we need to get a human involved? How many of those do 50% of them processing is good? Or maybe not. Maybe we need 99% of them or 99.99% of them. Who knows how many we need? And this is a question that we have to answer. What is the right level of reliability? What is the target that we want for that particular service? And then finally, the S that I want to talk about is the SLA. Now, you've probably heard the term SLA before. You probably even have used SLAs with service providers that you have. Either you're providing an SLA as a service provider, or you might be consuming or a party to that SLA through some service that you're consuming. But here's the thing. An SLA is something that an SRE should stay as far away from as possible. SLAs are really the language of business, and they're the realm of attorneys. An SLA is typically an agreement between one business and another business. And what happens when you fail to meet your SLA? Typically, if you're the one providing that SLA, it means you have to give your customers money or you have to give them credit. And I don't know anything about your business, but I'm pretty certain you're not in the business of paying your customers. And as a site reliability engineer, I definitely don't want to be in the business of us paying our customers. But also, an SLA is an interesting thing. I was looking at one SLA recently just to kind of come up with an example of this. And an SLA for a particular service that I was looking at said that we guarantee that the system will be available 99.5% of the time. And if we miss that in 3 consecutive months, then you're due some credit. Okay, so now let's imagine that you're a user of that system. And this month, everything is going fine. Next month, things are pretty bad. They're pretty rough. Every time you try to use it, it seems to not be working. You're starting to get frustrated. You get frustrated enough that you pull out your contract, right? You pull out that SLA and you look at it and you are angry. This service keeps falling over. And that contract says, well, yeah, but we have to fall over 3 consecutive months in a row for it to matter to us. You're not happy as a user. As an engineer, I'm definitely not happy, but I also want to stay away from that contractual obligation. So look, when we talk about SLAs, I really just say, yes, they are important. They're definitely critical, but they're not a thing that we use in the everyday language of SRE. So let's go back to the service level objective and really focus in on that for a minute. Because an SLO is the target for the overall health of your service. So what should that target be? How reliable do you want your system to be? Well, within Google, there's a gentleman named Ben Traynor-Sloss. He is our VP of 24/7 engineering. He's one of the founders of the practice of SRE within Google. And he's known for saying that 100% is the wrong reliability target for basically everything. And why is that? Well, of course, you and I know, maybe, I don't think this will surprise you, it can't be achieved. We can't run systems that are 100% reliable. But also, our users don't actually require that. In just about every case, a user does not actually require 100% reliability. And maybe as importantly, our time, our engineering capacity, the work that we do can be better spent on delivering value that our customers do need, or value that our customers do care about. Sometimes we call those features, changes to the application. So with the practice of SRE, we recognize that we should not set our availability target, our reliability target, our SLO, at 100%. That gives us something that's between our target and 100%. That space in between we call the error budget. Because the fact is that if you target 100% reliability, it means that you are also targeting 0% unreliability. So think about that for a minute. If you start at 100% reliability, you demand perfection. And any single failure that you have, no matter how small, must be treated as an emergency. Think about what happened just earlier tonight, before maybe you joined. Jeff was on this Zoom. We were talking. Jeff was like, it's beautiful. I'm going to go outside. And Jeff walked outside. And as he was moving around, he didn't even know this probably, but his signal kind of broke up. So he was talking and we all lost his audio. And then he came back. In a system where that was 100% reliability that was required, there would have had to be a Zoom engineer who jumped into the system, figured out what was going on and solved that problem. That would have been an emergency. We know that we can't get there. We know in truth that the only truly reliable system is one that does nothing at all. It can never change. It can't have anything change around it. It exists in a vacuum, hermetically sealed from the rest of the world. It's all by itself. It's impossible. More than impossible, though, it's virtually useless. Who cares about that system that nobody can touch? It can't ever change. It's off there, sealed away. So we set a reliability target for our service. Let's say that target is 99.9 or 3 nines reliable. Our error budget is then 100 minus that 99.9. So we have a budget of 0.1%. So when you think about a service, what does it mean to have a budget of 0.1%? If that service handles 1 billion queries a month, that means we have 1 million errors to spend per month. And that's what we call our error budget. But you might ask, and you wouldn't be wrong to ask this, how do you spend an error? What does that actually look like? So as I mentioned earlier, it's actually about recognizing that we have capacity constraints throughout our organization. We need to prioritize the work that we do. Focus on the most important things right now. So SLIs, SLOs, and error budgets allow us all to speak the same language of reliability. And when I say all, I mean all of us. It's developers, it's operators, it's SREs, it's product managers, it's even those people that we call the business. They have to speak this language along with us. We all want to deliver concepts to market as fast as possible, but we want to do that while meeting our reliability goals. So the error budget itself actually becomes this great communication framework that we can use. We can use this communication framework to make prioritization decisions. We only have a finite capacity for work, so how and where should we deploy that capacity? We can let the system guide us. If we're not meeting our reliability requirements or our reliability goals that we've set for our customers that we've agreed to, then we should take that capacity and focus it on things that are going to make the system more reliable. At the same time, if what we find is we're meeting our reliability promises and we have lots of budget to spare, that is also a signal from the system. That signal is telling us that we probably aren't learning enough. We aren't experimenting enough. We could spend time moving faster. We're being too safe. So think about this when you start thinking about what are the actual reliability requirements for my service. And a good way to figure that out is to ask, how reliable do you want this service to be? Well, there's one problem with this. If you go to the business, if you go to your customers, if you go to the product owners and you say, hey, how reliable do you want this system to be? Let's actually change the conversation. Let's go to the CEO of your organization, CEO of your team. Hey, CEO, how reliable do you want this system to be? Here's the answer you're likely to get. Duh, I want it to be all of the reliable, 100%. In fact, Arsh, I believe in you. Please make the system 110% reliable. If you do that, I'll get you a bonus and a promotion next year. So, of course, we'd love to get there, but we can't do that. We know that 100% is the wrong reliability target. Sorry, Arsh, you just walked away. I gave you a promotion and a big bonus. I don't know if you heard.
I heard it.
But it's because you've made the system 110% reliable. So thank you. But listen, that's not achievable. We know that. So I like to rephrase that question. Don't ask, how reliable do you want this system to be? Flip that question around. When do we need to make a service more reliable? Now, this, I think, is a much better question for having a conversation. When do we need to make the service more reliable? A good answer for that is that we need to make a service more reliable just before our users stop using it or otherwise become unhappy with the service. We want to keep our users happy. We want them to continue using the service. So if we notice that they've stopped using the service, they've changed their behavior in some sort of negative way, it's time for us to make that system more reliable. It's probably past time, actually. So one way to approach this question is that our targets or our SLOs should capture the reliability levels that keep a typical customer happy as long as we barely meet those goals. How's that for some good engineering for you also? I want to keep a typical customer happy, but I want to do as little work as possible to get there. And I just want to barely meet our goals and then keep that typical customer happy. We call this the happiness test, but it does really help us determine if we've set good targets. So by using this happiness test, we know if we're meeting our SLOs, our customers are happy. And if our customers are sad, it's probably because we're missing our SLOs. But it is really important to test your SLOs on a regular basis. If you are just starting with SLIs and SLOs and starting this conversation, starting to gather these metrics, you're probably wrong. You've probably set the wrong targets. Really help us. Remember, our monitors don't decide our reliability. Our users do. So if you find that your users are unhappy, but you're meeting your SLO target, you've probably set the wrong target. Or maybe you're looking at the wrong service level indicators, or maybe both. It's also really important to remember that our users' expectations change over time. So the thing that keeps a typical customer happy today might not be enough to keep them using your service tomorrow. So we want to understand what that is, and we need to continually revisit that, refine our SLOs. So what targets should you set? Well, obviously, it's the targets that are going to keep your users happy. But remember, when we set these targets, we have to remember what is the outcome of missing this target. We're going to use the error budget to help us balance that reliability or to help us make prioritization decisions. And we know we want to spend as much of our time and capacity prioritizing velocity, shipping features, moving fast, so that we can continually improve the customer's experience, continually to give them new features and keeping them happy about the reliability of the service, right? So we want to move as fast as we can while doing that in a way that is safe. And that's what we really want to focus on when we start talking about SLIs, SLOs, and the whole practice of SRE. But successfully operating a service, obviously, goes beyond just these particular ideas, goes beyond SLIs, SLOs, and error budgets. There are other things that are the responsibility and part of the role of a service reliability engineer or an SRE. So successfully operating a service actually entails this wide range of activities. You have to develop monitoring systems, plan capacity, respond to incidents, learn from incidents, all of this. So we've developed this reliability hierarchy, but I'll tell you what, between you and me, I think this reliability hierarchy is a little bit misleading. If you look at it, you may find yourself saying, oh, we've got to work on that monitoring. That's the foundation. And in fact, you may find yourself continually working on the monitoring and never moving to a higher level activity like capacity planning because your monitoring still isn't correct. So you might think also that the bulk of your engineering capacity should be spent on monitoring, like it's the widest part of this triangle, so clearly. So look, no model is perfect. Maybe think of these activities as tags or attributes that you might use to label some of the work in your backlog. How much of each of these does an SRE on the team work on? That can largely be driven by the service itself. If it's a brand new service, just going through an initial prototype, one, you probably don't know what keeps your users happy yet. It's an initial prototype. Second, maybe capacity planning is less important than monitoring. We need to figure out, how do our users care about this system? Are they happy with it? Are they using it? On the other hand, if your monitoring is saying, hey, you have capacity issues because you've had some explosive growth recently, you can't say, well, our monitoring still isn't perfect, so we got to stay down here at the bottom. It's time to listen to those signals, right? And go and work on capacity and adjust your engineering focus accordingly. And again, you can use that error budget to help with that. Another good place to start. So when we think about how do we start bringing these practices and bringing this mindset into your organization, SLIs, SLOs, and error budgets are a good place to start. But sometimes you'll see some resistance to them. Another great place to start is with incident response. I say this is a great place to start because I don't know anything about your business. I already told you that earlier. It doesn't matter how big you are, how small you are. The truth is something is broken, probably right now. No, I'm sure all your systems are fine. Stay here. You don't have to go check on them. They're all fine. But they are likely to break. They will break all the time. Not all the time. They will break on a irregular basis, but you know what I'm saying. Incidents happen, outages happen. We have to make sure that we have good incident response practices. How do we make sure that the outage is as short as possible? Do we have a clearly defined incident response program or a process? Are we collecting the right information through our monitoring and other ways of capturing signals about incidents and about the health of our systems? And the beauty of incidents, John Allspaw likes to say this, an incident is an unplanned investment, right? So when you have an outage, you just made an investment in your system. And by your system, I don't mean like, this computers. Well, I mean the computers, but I mean the larger system, the people, the process, all of this, the socio-technical system, if you will. So when there's an incident or an outage, you just made an investment in that system. So you kind of have two choices. You can say, whew, we survived that. Let's move on. Let's get as far away from that as possible, as fast as possible. That's like spending, I don't know, maybe that's placing a bet. Your horse lost and like, that's it. You just walk away. But instead, if we take that bet, we take that investment and try to get a return on it, what would that look like? That would look like investigating the system, learning from the system what we can do to help make the system more resilient, what we can do to help understand why and how things break. We do that through investigations, through conversations, and through a truly blameless postmortem, where we focus on process, we focus on technology, we focus on people. We understand that everyone showed up to work to do a good job. And there was something about the system that changed that allowed that failure to happen. So let's dig into what that looks like. And when you do hold a postmortem, it is really important that you capture what are the actions that you're going to take coming out of this. What are the changes that you're going to make to the system? And in fact, if we go back to that error budget slide where you talk about which things should we prioritize. One of the things when you're out of error budget or when you're not meeting your reliability goals, one of the things to focus on is perhaps your postmortem items, the items that were uncovered during your postmortem. Because I don't know about you, but I have definitely been in a postmortem. We were all blameless. Everyone was kumbaya. We understood how the system went. We captured some action items. We put them onto the backlog. And then 2 months later, we had another incident. We went back into that postmortem. We started learning some more things about the system. We identified some actions, some corrective actions that we might take. We went to put them on the backlog, and we found that they were already there. They were still sitting there from the last time. We'd never done that work. Why didn't we ever do that work? Well, it didn't seem like a priority. We'd moved past that incident. There was no reason to do that now. We've recovered from that. But your error budget can help you make those prioritization decisions. And by having those conversations about the error budget and especially the consequences of missing the error budget with your collective team in advance, makes those prioritization decisions and questions and conversations much easier. We can let the error budget help us with signals. Should we work on more features, or should we work on more reliability within the system? There's always going to be a mix, but which way are the scales weighted? Your SLOs and your error budget can help define that and help you understand that. All right, I want to leave you with a couple of books. Now, the beauty of these books is that you can read them all for free online. Of course, you can also buy them from your favorite book retailer or e-tailer. Let me just talk you through each one of these books, and I'll tell you which one I recommend you start with. So the first book on the left is the SRE book, or Site Reliability Engineering. This was the first book that Google wrote. We wrote it together with O'Reilly, and this was all about how do we do SRE within Google. And it's a really great book full of a lot of great insights. Maybe some of you have read it. Most of the people, maybe not most, a lot of people that read that book the first time, their feedback was, wow, this is really amazing stuff, super eye-opening, and I get these, like, a new way of thinking about reliability. But here's the one small challenge. I'm not Google. How does this work for me? And that's what prompted the writing of the Site Reliability Workbook. So how do you take the principles and practices that we use in Google and apply them to your organization? And it doesn't matter if your organization or the systems you're building are built by 2 or 3 people, or if they're built by 20 or 30,000 people. In either case, the principles and the practices can be applied. And then finally, the Building Secure and Reliable Systems is the third book to come out. It was released earlier this year. What I can tell you about it is about building secure and reliable systems, but I haven't had a chance to read it. I have it over here on my desk, but I haven't really dug into it yet. So I can't tell you much about it. The thing I will tell you, if you're trying to decide which of these 3 books to start with, go with the middle, the Site Reliability Workbook. I find that one is the best in terms of how do you get started with some of these ideas. And it includes things like case studies from other customers or other users and adopters of these practices and principles, and sort of what their journey looks like. Because of course, not everyone's journey is going to be the same, even if what we're driving towards is typically like the same outcome, better reliability. All right, with that, I want to say thank you so much for having me. And I think we have some time for questions. So what questions do you have?
Nathen, thanks for the great presentation. So wanted to ask a quick question about working with development teams as you think about high availability systems and building in error budgets. How would you deal with a development team that fundamentally does not believe that their application can run multiple instances of it and it has to be up 100% of the time? Right.
So this is really tricky. The first thing you have to do is convince them otherwise. And there are a couple of tactics that I can give you to help you convince them otherwise. One is you have to ask them to come to the postmortems that you're having. We want to run another instance where we had an outage. Let's get in a room and talk about that. They have to feel that pain. I think another thing that you can do is you can point them to the industry. Like, look, if we want to make 100% reliable systems, like, look around, listen to other people in the industry that are telling you that it's not actually possible. I think it's also you have to understand sort of where they're coming from also. I think that if they want a 100% reliable system, a system that never goes down, like, you can engineer better reliability into that system. And so you have to partner with them, and they have to take on the ownership of building that reliability into the system, which may mean that they have to stop shipping the features that they want to work on and focus on how do we make that system more reliable. Maybe they need convincing that it has to be a distributed system. You have to be able to run multiple instances of this thing. It's the way that modern tech works. I don't know that like, outside of platitudes, any of that is actually helpful though, Adam. So what are you doing today to help them feel that pain, or to help them understand that 100% like is the wrong target? Or maybe I should turn that question back to you. Do you agree with that? Is 100% the wrong target? Can that be achieved? Should it be something that we strive for?
So I'll comment real quick on the 100%. I fully agree with you that 100% is the wrong target.
Yeah.
As another engineer on my team told me today, we were on a call with another large tech vendor that claimed one of their systems had 100% uptime guarantee in the SLA. And my fellow engineer said, before they claim that, they should realize the planet doesn't have 100% uptime guarantee. So unless they're engineering extraterrestrially.
Right. And that's like, to me, that's a great illustration of an SLA. A business can tell you, look, we guarantee 100% uptime. And you know what? I wonder if you'd like dig into that SLA, there may be clauses like, well, I mean, obviously scheduled maintenance isn't included in that. So it's 100% uptime, except for when we schedule maintenance. And then also, like, what are the consequences of not hitting that 100%? And so again, it might be something like, we guarantee 100% uptime, except during scheduled maintenance. And if we miss it 3 months in a row, then we'll give you like money back or something like this. So like, your service has to get pretty bad. Like, the way I think about SLAs is the service that you're receiving from that provider has to be bad enough that in the moment you go and find the SLA to figure out, have they violated it? Look, you're already unhappy. And typically when you're you have to be really unhappy to pull out the SLA. And unfortunately, in many instances, you'll find that although you are really unhappy, they have still not violated that SLA.
So I've got an interesting question about this, right? Because I feel like the magnitude of a lot of this terminology changes quite a bit when you start looking at scale, right? So, I have, I don't know, approximately like 1,000 requests a month or something, right? Now, this is relatively heavy usage for the users of my service. But right, obviously the numbers and the percentages change quite a bit, right? So when you're looking at 2 or 3%, those are like catastrophic when you're looking at 1,000 requests. And so like, how do you wrap your mind around sort of scaling these things, right? Because at a handful of clients and a small number of actual page views, right, we are kind of trending toward needing 100%, because otherwise I get a phone call.
Yes.
But obviously, as soon as you start getting up into the millions of page views, and you're like, yeah, like 1,000 errors, like, okay, like a web app missed a database connection and nothing happened and no data was corrupted, just refresh the page type of thing.
Right. And I think you've basically answered your own question, or like I'm just going to repeat some of the words that you said, right? Obviously scale matters, right? I said that, like, when I was talking about the error budget, I'm like, well, you have 1 million errors to spend this month. And based on how you described your service, you'd be stoked if you got 1 million requests this month, let alone 1 million errors to spend. Like that's crazy talk. That would be amazing, right? That's the scale that maybe you want to move towards. So how can you take these principles then and apply them to your service? And I think part of the thing that's really important is really understanding your users and the use cases. I'm going to use another large scale system to describe or to make this point. And I'm going to use Twitter for that. So if you go back to the early days of Twitter, what was most important to Twitter at that time was getting new users to sign up. And so what they cared less about was that after you signed up, like, they had to. So if you saw the fail whale 5 times a day because they couldn't show you the tweets, like, they weren't super happy about that, but also signups were still working. They were pretty happy, right? That was the thing that the business was prioritizing, that they needed to prioritize to build that network effect. Today, the system is more reliable. Like, we all feel it. If you've been a long-time user of Twitter, and by long time, I mean, like, you've used it for a decade or whatever, it's way more reliable now than it was back then. Their business goals have changed, right? And so I think it's really important that when you have a system that has 1,000 requests that you're seeing a month, yeah, that is it is a completely different approach. But in that case, like, with 1,000 requests a month, you can probably, maybe not quite, but almost talk to every single one of your customers in that month, like, with your voice, like we're doing right now. When you get to the scale of 100 billion queries a month on a service, I can't go talk to all of those users, right? But being able to talk to those users also helps us really identify, what do they need? What do they really prioritize out of the system? What's catastrophic for them? Is corrupting data catastrophic? Maybe so. And so how do we put in mitigating, how do we mitigate these happening? Like, again, that's the signal from the system that maybe we need to slow down our feature work and improve reliability before we ship that next feature.
Yeah, that makes sense. Yeah, we just went through a phase in our company where we started seeing a lot of regressions every time we were trying to release new features. And so what we did was we stepped back and put on, like, a feature freeze until we had time to build our full CI pipeline for this. And that was interesting because as part of our plan, not only did we do that, we also imposed sort of organizational things like, no deployments on Fridays, which I, in hindsight, realize is, like, fairly standard for a lot of companies. But yeah, no deployments on Fridays, and nothing after 4 p.m., especially because a lot of our clients are East Coast. So ideally, it's even like deployments are 8 a.m. to noon, Monday through Thursday. And that played a huge role for us, as well as, having a full-on staging environment that was exactly the same infrastructure. And so what we found was when we started instituting those policies, it definitely slowed down our dimension. We stopped getting 2 a.m. wake up calls.
Yeah, absolutely. Your organization and your company, you've maybe never used the words, but you have SLIs, you have SLR, and you probably saw that, right? Whether it was because they called you or what, but there was some indicator that you were monitoring, whether you were intentionally thinking about it like that or not. That was a real thing. You missed whatever that target was, and then you changed your behavior. So the change in your behavior, that is taking on the consequences of missing your service level objectives. So you've like taken on the consequences of the error budget, and that gave you a signal that said, hey, when we're doing deploys, every deploy that we're doing seems to cause problems. Maybe we should change in your behavior that is of the code, of the changes that we're making. And that certainly led you to more automated pipelines. And then certainly, as you mentioned, led you to probably more testing. And hopefully, or if not yet, it will, led you also to smaller releases, right? Like, let's not, and I've certainly been in this position, like we do 2-week sprints. We deploy at the end of every 2 weeks. And then, so at day 14, we deploy. At day 14 and a half, we roll back. And then at day 16, we deploy, right? And so that's what our 2-week sprints felt like, right? And that was a real problem. And frankly, in that instance, we went to the business and said, we know how to fix this. We're going to deploy more frequently. And the business said, whoa. Every 2 weeks, you cause major disruptions for all of us. You want to do that more? And so we had to help convince them and bring them around. And frankly, we had to build the trust to say, yeah, we want to do that more. Watch this. Oh, we just did a deploy while this conversation was happening, but it was so small, it was less risky. And now we can do those a lot more frequently.
So just building upon that, so that's one thing that we've tried to institute at my company, right, is smaller deployments. But and I think some of this is maybe specific to a startup where it's like you're guaranteed to build the wrong thing first, and then you have to go back and retrofit stuff or bolt on things. And so like, here's an example. The original version of what we built was not multi-tenant. And so we ended up building this whole multi-tenant branch, and then it was just like a massive hurdle to actually release that. So how does that sort of scenario fit into an SLI and an SLO?
Yeah. So I think that SLIs and SLOs are really about the production systems that are running, right? And so I think while DevOps and SRE are very much related, I think that this really, like the problem you described, really points upstream to what most SREs would traditionally care about. That is about your development processes. So how do you, like, the first thing you said was we created this branch over here to do multi-tenant. And like, I get why you did that. And also, you probably know like that's not the best way to do that, right? But the better way to do that is to do trunk-based development and not have long-lived feature branches. But in order for you to get there, you have to make investments in your system so that you can take that multi-tenant thing and break it down into small chunks that maybe you can deploy, that is code that's not turned on, right? It's like dark code in production. So like, there's a lot of maturity that you have to grow, and the only way you get there is by doing it, right? And by learning it. And so you learn the lesson of why are these like long-lived branches bad. Now you have to build the practice of how do we get to a place where it's something closer to trunk-based development. Oh, you're muted there, Jeff.
Yeah, so I actually don't know what trunk-based development is. Can you tell us about that?
Yeah, for sure. So trunk-based development, trunk-based development is this idea, this practice, where we say we want to eliminate all long-lived feature branches. Every developer should be taking their code and integrating it into trunk, whatever your trunk, like mainline, master, trunk, base, whatever you call that, right? Into the main line of your code base. And that main line should always be deployable. And so you want to get into a place where, as a developer, you want to work on a feature. You really want that feature to be broken down small enough so that it at most takes you a day to work on that bit of the feature. You then take that code, you check it into your main line. So you're practicing continuous, it's basically continuous integration, right? And when you check it into that main line or that trunk, your automated tests are run, your build is created. And when you see that test fail, you as a team, you have this agreement that, hey, when the build turns red, we all stop what we're doing and we prioritize getting the main line back into a deployable state. And so, great. Thank you, Solomon. I would totally take you to that link that Solomon has posted in Zoom. That is an article about trunk-based development. And in fact, if we have another moment or so, let me just show you one other quick thing here. Okay, so you can see my browser again, yeah? Let's see, I wanna take you over here to cloud.google.com/DevOps. Since DevOps is your theme, right? And so at this site, we have done through I don't know 6 years, a ton of research into software delivery and operations performance and what makes high performing teams. Now, the thing that I want to show you really quickly is that there is what we call a DevOps quick check here. And I'll just walk through it really quickly. So with the DevOps quick check, and this applies to teams of just about any size, we ask 4 questions. I just lied. We ask 5 questions. The first question we ask is, what's your lead time? And in lead time, what we really mean there is the time from the code gets committed to the repository to the code is in production. So let's go back to, we'll use the same example that I talked about where we deploy it every 2 weeks. So in that instance, when I committed a line of code, a change into the version control system, within a week to a month, because it might have been 2 weeks, that would land in production. How frequently do you deploy is the second question. So how often are you pushing that button to push that code out? We were doing it between once a week and once per month because we were doing it once every 2 weeks. When there's an incident, how long does it take you to recover from that incident? We were not terrible at that, like less than a day, but not consistently less than an hour. And then finally, what is your change fail percentage? So the change fail percentage is I pushed a change to production. How frequently are those changes failing, right? And so in our instance, it was, I'd like to say it was 16 to 30. It was probably more like 31 to 45. And then the 5th question is just what industry are you in? We happen to be retail, consumer, e-commerce. So you answer those 5 questions, and then you can see where do you sit relative to all of these participants of this survey that have taken this survey, and we have data from 6 years, tens of thousands of developers in organizations of every size in every industry. So this puts us at a medium performer. But the next thing that you can see here is that we say, hey, if you want to get better, the 3 things that you should consider focusing in on are continuous integration, continuous delivery, and architecture. And in fact, we take it a little bit further. So first, each one of these is an article in and of itself, so you can go read about each one of them. But there's also a further sort of second step to this quick check that will help you prioritize of these 3, which ones should you look at? And we do that prioritization through additional questions. All of the questions fall on what's called a Likert scale. So you rate it from strongly disagree to strongly agree. I'm not going to read these questions. You can. I want to answer them so we can see what happens next. And like I said, I'm not reading them. I'm just going to pop in a bunch of random answers. So there were 4 or 5 questions on continuous integration. Here are questions on continuous delivery. And the idea behind this, much like I said at the beginning, we use that word DevOps. What does that mean? You say continuous delivery. What does that mean? Well, we have data and science that can help us answer those questions and back up what you should work on. So we do some, based on the answers that you give, we're going to do some statistical analysis in the background. And when you view the results, it's going to show you, based on the answers that I just gave, of the 3, continuous integration, continuous delivery, and architecture, the place where I'm performing worse than my peers, where there's the biggest delta in this particular one, was continuous integration. So now this is a signal to me as a team. What I need to do is build up our practice on our team of better continuous integration. And like I said, there's articles about each one of these. So if you go over here to view the solution, you'll see things like, what is it? Like, what's a definition of continuous integration? What does that mean? How do you implement it? Some common pitfalls that you might run into. How do you measure it so you know what progress you're making, and so forth. So that quick check is a great way to help your team identify some software delivery and operations practices or capabilities that you need to put into place or that you should focus on. Now, the other thing that you can see on this, I'm back at cloud.google.com/DevOps. This is all based, like I said, it's all based on research. You can actually explore the research program here. And so these are all of the capabilities. You can kind of explore this chart a little bit, but I just want to show you really quickly the capability catalog down here. These capabilities, some of them, like continuous integration, are technical capabilities, but there are also process things, like how do you streamline change approvals? How do you have visibility into your value stream, working in small batches? There's measurement, and then there's cultural capabilities as well. So measurement is like work in progress limits, monitoring and observability, and then culture, like what's job satisfaction look like? What is do you have a learning culture? Process transformational leadership. Are your leaders doing the right things to support the teams in achieving these goals? This is like, in addition to the SRE books, this cloud.google.com/DevOps is a really, really solid resource for you. That was a really long answer and an extra demo to your question, Jeff. So I hope that helps get you like on a path.
Yeah, much appreciated. I think that helps me as a programmer and technical founder sort of like bridge that gap from theory to practical knowledge.
Absolutely.
I do have to step out, so Arsh will kind of take over managing the Zoom stream, but thank you again for being here, Nathan. I'll let you guys keep chatting here.
All right. Thanks, Jeff.
You guys.
Thanks for arranging it. Take care.
So hold on. Okay, does this work? I have a question. So you said feature branches, right? The whole Git flow, whatever. How does? So I was on a team before. Where how do you improve, or how do you make sure you're following the model where you're always deployable, but you're waiting on code review?
Yeah, this is a really good question, and this article here on Trunkbased development will talk a little bit about that. But I think it comes down to a couple of different things. First, code review, first, code review is really important. You know, the best way to do code review, the best way to speed up your code review is to do pair programming. Because if you're doing pair programming, someone else has already reviewed that code as you're writing it. So now you aren't blocked by waiting on someone else to do code review. The other thing that will help you with code reviews, number one, if you make smaller changes, they're easier and faster to be reviewed. Number two, if you as a team have a practice where you prioritize code reviews, right? Look, I'm busy writing this feature. I don't have time to review your code. Well, every minute that you spend continuing to work on your feature is I spend continuing to work on my feature, I'm blocking you. And this, like the real downside of that is, and at scale it gets even worse, is that we're making a local optimization. I want to get my shit done. I don't care about the system, right? And we need to kind of have this systems thinking approach. So when something's blocked, we have to unblock it. And this is the other thing that can be really difficult with code reviews, quite frankly, is when you have distributed teams, right? So yeah, I'm done with this feature, but the people that are available to do the code review or authorized or capable of doing a code review for this are in bed asleep. I'm not going to wake someone up for that. So the other thing that you can do is when you do code reviews, how much of that can be automated, right? So certainly your code reviewers shouldn't be doing syntax review for you, right? Or like style guide reviews for you. build that in, right? You should have a linter for whatever language you're using, whatever style rules you have within your organization. That should be something that as a developer, you don't need to wait for another developer. Your system can automatically test that for you. And then at the end, if and because you're going to have these code reviews, like I think it is a matter of recognizing that those are that the longer a piece of code sits, not moving through your pipeline, that the more likely it is to cause a problem later down the line. So you have to prioritize them much in the same way that when the build goes red, you stop and fix it. Maybe you set a work in progress, or like maybe you even like you could take on some of the SRE principles and sort of mutate them towards your code. We have a service level objective that says a code review will happen within N hours. And when we fall below that service level objective, that's a signal to the system that, hey, we need to stop and focus some time on code reviews to unblock that so that the system, that things can keep flowing. So you could do that with something like a service level objective, right? The consequence of missing that is that we focus time right now on code reviews. You could also do it with like a work in progress limit. So if we hit 20 code reviews that are in the queue, no one should add another code review, because all that does is make the system even slower. Like it gets worse and worse and worse. Once we hit 20 or whatever N is, right, your work in progress limit, that's the signal. All right, everybody, pencils down. It's time for code review.
I guess now the question is like, what if you have a legacy app that wasn't built for CI/CD?
Yeah. So there you need to figure out, like, you need to put some work into how do we get that into a place where we can add in tests, where we can add in automated tests, where we can start thinking about that. Frankly, you have to set aside some of your capacity, your engineering capacity, for improvement work, right? And again, this is a thing where if you know, the error budget is about a framework for having a conversation about what should we prioritize. So you can use that similar idea to say, hey, listen, if we find that this legacy app is always failing, or that when we want to make changes, it takes too long to make changes, then you can't fix that in the moment, but that's the system telling you need to invest that time elsewhere. And look, it's easy for me to tell you that here in a meetup also, and harder for you to convince your colleagues like that are pressuring you, no, just go faster. Don't slow down to make things better, just go faster. You have to convince them. You have to help them understand that.
So you think it's worth like a sprint or two to sort of step back and bring it up to this point where in the future you can increase your velocity?
Yes, it is absolutely worth that investment. The challenge, though, here's the challenge. A sprint or two can quickly become a sprint or 20 before you ship another feature. And you know that as well as I do. So if it's not a sprint or two, maybe it's 20% of our capacity is going to system improvements, and 80% is going to the things that you want to move forward. And when we make a system improvement, maybe, or we like when we get better flow out of the system, like let's say we improve the flow by 10%, we agree in advance that extra 10% is going to go to new system improvements, not to faster feature delivery. So you start like compounding that interest, if you will, until you get to a place where you are able to move faster. And the truth is that takes commitment from not just the engineering team. And so you have to get that commitment and buy-in from across the board.
Yeah, that makes sense.
Nathen, thank you for the talk.
Yeah, you bet.
I'm still stuck on this trunk-based development. I'm going through my head thinking like, okay, when we have long-running feature branches, they're typically major architectural changes.
Yeah.
How can you take a major architectural change
Yeah.
into something like trunk-based development? That doesn't.
Yeah.
I'm trying to wrap my mind around that.
I know.
Like switching a JavaScript library. Like, let's say you were on, we were on a traditional like MVC approach and then implemented Angular.
Yep.
Like, I couldn't imagine committing that to master every day. Like, how do you
Right.
get there? Something major.
Yes. So there's definitely some there's some like guidance in this article, but there's also a whole website that's dedicated to this. I think it's called, give me 1 second. Let me find it. I think it's a really easy name also. Yeah, it is. It's trunkbaseddevelopment.com. Yeah, I would. So look, I hear you, and what's going to blow your mind more is that the next step beyond trunk-based development is a mono repo. Like, put all of your code into the same repository. So if you think trunk-based development is a hard thing to wrap your mind around, how about a mono repo where all of your code lives in one repository? Because that will make things better also. So what I've just done is say, yeah, I hear you. Trunk-based development, hard to wrap your head around. Wrap it around something bigger. But what I haven't done is help you wrap your head around trunk-based development. Just giving you some more resources.
So Nathan, real quick question. So I know Google loves monorepo.
Yeah.
And my organization, we've talked about this publicly, we are also shifting to a monorepo. I personally have done multiple repos. How have you found that the DevOps principles of like CI/CD and improved monitoring and SRE, how are those positively benefited from moving to a monorepo?
Yeah, so I think that things like CI/CD are they, like, to be quite fair and frank, when you move to CI/CD, when you move into a monorepo and you want to do CI/CD, on the one hand, your CI/CD system becomes more complex. And really, I like to think about it as who is responsible for eating the complexity, right? Do you want your developers eating the complexity? Do you want the production teams eating the complexity? Do you want that complexity to land somewhere in between? And I think that within Google, there's this beautiful thing. Right now, I could go to any part of the Google code base, because not only is it a mono repo, but everyone has access to it. Like, I could go to any part of the Google code base and submit a change request or a PR. I could get a change into the system right now in any part of the system. I could go change Android. I could go change Google search. I could clearly change our website. So I think that to get there though, like, yes, there are different types of complexity and different parts of this like life cycle where that complexity exists that you have to account for. The beauty of a mono repo is that, with CI/CD, like, the CI/CD pipeline looks very similar. The other thing that's true at Google is where we're deploying looks pretty similar. Like, the way that systems run within Google on Borg, which is, our Kubernetes thing, every application runs on Borg. So every engineer has enough understanding about the deployment environment, and it's not different for every single application. So all of that helps. That's not to say that that complexity disappears. You move it around.
What guidance or material is out there for other industries which require, say, higher SLOs or SLIs, like telecom or healthcare and whatnot, especially when you think about, hey, E911, that needs to be up a long time,
Yeah, well, I think frankly, it is always about understanding who your user is, what are their use cases, and then making the right like you still have to make architectural decisions about that. You still have to like look. There is a difference between I don't know, a single server staying up 100% of the time and a service being available 100% of the time, right? Those are two very different things for sure. But even that service available 100% of the time, boy, to get there, you have to, there are huge investments that you have to make. Absolutely, absolutely. And we definitely have, large organizations. There's probably, I'm trying to think about in the SRE workbook, who the case studies are. I know there's Home Depot. There might be Evernote. I don't know who else, but I can say that we have definitely worked with telecoms. We work with telecoms. We work with financials. We work in the healthcare industry. Like, yes, and we bring these SRE practices into those organizations for sure.
Okay, but you think there's something in the workbook that might be some?
Yeah, I would start in the workbook, and yeah, go from there.
Okay, because it's been hard to find, like specific guidance, particularly for say telecom, especially when you're going from a traditional telecom organization that had, say a BSS and a OSS side of the house, and then a traditional IT side of the house. You're trying to merge all those together, kind of converging all of the lines of business together. So.
In fact, this one, it looks like there might be some good stuff here that goes beyond just SLIs and SLOs, but this is, sorry, I put a link in the Zoom chat. It is chapter 33 from the workbook. Actually, it might be from the SRE book, but it is lessons learned from other industries. So I would definitely start reading there.
All right, great. Thank you.
Yeah. Yeah. There's a lot of words on that page, so
I have a
that'll
question.
keep you busy for a minute at least.
I have a question about monorepos. How does that, I mean, I understand the advantages of having your code base in one VCS.
Yeah.
But how does that affect onboarding new developers who are really, so like, for example, like I'm guessing Google uses Go for the back end, right? And then like say you use Angular for the front end. So like, so how do you make sure like developers who you hire for the front end aren't really overwhelmed by understanding the back end part of the code?
Yeah, for sure, for sure. It takes an investment in, like, when you join Google, you go through an what we call EngEDU, or engineering education. Like, you go through a training program that introduces you to all of the tools within Google. The other thing that is absolutely true is that a lot of those tools were built in Google. You can't experience them elsewhere. There's a huge investment in those tools, in that training, in the process, right? And so that's how we onboard new engineers, frankly. Like, and yes, it is all one repo. Obviously, like, if you go to a particular folder, you're not going to have your Angular and your Java and your C++ all like mixed into that one folder. There's certainly a layout to the repository that helps keep you, like, you're going to work in your part of the repository, but it is all in the same repository. And the beauty of that is, or the challenge, right? When you think about, let's say that you are using a JavaScript framework like Angular, and you want to upgrade Angular. Well, everyone's using the same version of Angular, or everyone's using the same version of that library. And so there are rules about how do you bring in a new library or a new component. There are maintenance things like, okay, if I'm bringing this on, we have to upgrade it. And when we upgrade it, it's going to impact a bunch of different systems, a bunch of different parts, because there's one copy of this library in the repository, right? It's but on the other hand, you don't run into a system where, man, I've got these 27 different applications deployed in production, and on these 27 different applications, I have 24 different versions of this library.
So how do you do it? How do you upgrade Angular?
Yeah, so we very carefully, I guess, is it like, but very carefully with a ton of automated tests and clear like policies and agreements around who's responsible for which pieces. When you upgrade a library, what responsibilities fall on the owner, like of that library? And if it's not the owner of that library internally, like if one of the consumers needs it, then when they go through that upgrade process, they have to understand the implications on other teams, and they have to get buy-in from other teams. But all of that is, it's extra work, and it sucks, and it's hard, but it happens during development. It doesn't happen in production, right? And when you have that, like a multitude of different libraries deployed, now your SRE practice, like how do we monitor that? How do we know how these things break? Well, this broke this way. Which version of this library is it using? Is this system over here likely to break in a similar fashion, or is it going to break completely different because we're running two different libraries of that? So, yeah. There's, I'm sure there's books that we've written about that, and I'm not the subject matter expert there, but there's some words for you.
So how do you guys ensure that all developers are on the same page? So you have feature branches, right? So someone may be working on, say, making a change to the back end. Someone at the same time will be working on the front end. But if the front end interacts with the back end, you have to make sure that the front end developer has the recent changes to the back end. So like, how do you run your, how do you make sure, like when you're doing this Git flow where you have feature branches, like everyone is on the same, like the same code base, so to say?
Right. And this is, again, why like trunk-based development makes it a lot easier when you don't have all of these various feature branches, right? What we're doing with feature branches really, and this is like trunkbaseddevelopment.com talks about this in a way that I really like. What you're doing is you're increasing the distance between like your knowledge and what the truth is, right? And so the minute you create a branch, the truth is in that main line, and now you're further away from that. And the longer that branch lives, the further and further you get away from the truth, right? The more distance you have from what's reality. And I think that is really, really challenging, and you run into lots of issues because of that. And I think Git flow, again, that trunk-based development website will do a much better job talking about it than I will, but it is really, Git flow is built in such a way that, look, I think the intent behind Git flow is good, and I think the outcomes sometimes aren't as good as what you would hope for. That said, if it's working for your team, like don't fix that because Google said trunk-based development was better. Fix it because you're experiencing the problems that trunk-based development will help you solve. So don't just cargo cult ideas, right? Even everything I said tonight, like you can't just take it and apply everything to your organization, to your team, to your application. You have to understand sort of where you are and be very clear about what goals you're trying to achieve, how you're trying to improve, and then work on the things that are holding you back there. All right, with that, I'm on the East Coast also, so I'm gonna go grab a beer, and I want to say thank you all for having me. It was super fun conversation. I am in the Slack, and I'll at least hang out in the Slack for another couple of days. So if you have questions or anything that come up, feel free to hit me in the Slack, and I'll share the slides with the team here. So however you all usually distribute them, you can do that, and my contact info will be in there as well.
Thanks for staying up.
Cool.
Right.
Thank you so much, Nathan.
Yeah, thank you all.
Awesome.
All right.
Cheers.
I have one last question from the stream.
Yeah, sure.
This is from Adam Levy. He says, I think with monorepos for the duration, you must keep a branch alive. It generally goes more smoothly when you regularly merge the trunk back into your work in progress branch frequently.
Yeah, I hear you. I hear you. Let me tell you my experience, right? So this is the main line, and I'm a developer, and I'm going to work on something that takes a long time. So I create a branch over here, and every day I take that main line and I merge it back into my branch. That's great. I'm like practicing continuous integration, right? My main line is always going into my branch. But here's the problem. Arsh, you're a developer also, and you started another feature around the same time I did, but you're merging your master or trunk into yours as well. So now we've both moved along. The main line has moved along. It's fine as long as I get to merge my thing back in first. But for the second person to merge their stuff back in, ooh, that's when it gets really painful, right? And they won't just do that, right? You'll merge your stuff in, and then they'll have to merge their stuff like that into theirs before they can merge it back into there. Well, guess what happens while they're over here resolving issues? Someone has started up another branch and merged it back in. And so now we've resolved the merge conflicts with your branch. And guess what? Now there's another branch that got merged in, and now we're just stuck. And I'm sure that there are teams who have felt that pain for days, for weeks. I'm sure there are teams who have felt it for months. Yeah. Like, I know. And the reason I know that pain so well is because I said those words. Yeah, of course, we do continuous integration. I start this branch, I merge master into it every single day. Master goes into that branch. That is not continuous integration.
Yeah, no, it's funny because I work on a project, and our advisor hates branches for that exact same reason.
Yes. But you're well practiced in Git flow. Your team understands that. They have the mental model for that. To move away from that, to move towards trunk-based development, like I said, it's not going to happen overnight. It might not be the thing you should focus on, but when you focus on it, the way that you're going to get better at it is by doing it. And it's going to be painful. It's going to be painful, just like it was painful when you maybe not, Arsh. I was going to say, like when you switched from SVN to Git, but you look younger than me, so maybe you never were on SVN. Maybe Git was always your thing. but look, this is why, frankly, this is why a lot of us got into technology, so that we can continue to learn and change and improve our practices. And what we end up doing is we get comfortable in our ways, and then we stop improving. And I get it, like, because I'm an engineer also. I only want to do as much work as possible, as required, right? But there are definitely things that we will continue to learn, new practices that you will continue to develop, and habits and so forth. And much like you all use version control systems, can you imagine writing code right now without a source code repository? Can you imagine doing that and running that code into something that looks like a production environment? We would never go back. We would never go back. But there was a time, I can virtually guarantee there was a time where you logged into a production server and changed a file to see what would happen. I'm sure I did.
I mean, I've done that last year, so yes.
Yes.
All right. I guess yeah, it's late on the East Coast, so unless there are any last minute pressing questions, I guess we can let you go, Nathan.
All right. Hey, thank you so much. Y'all enjoy the rest of your week and weekend, and yeah, thanks for having me.
Yeah, thanks for a great presentation. Have
Thank
fun.
you, Nathan.
All right.
Bye-bye.